In this video, I just want to quickly look at, I say quickly, but we're going to look at solving equations. And we'll look at equations such as this here. And then we'll look at some other equations looking like this here. And the key thing to understand about an equation, so if I quickly write this down here. So if you look at this equation, we got x add 2 is equal to 10. We have a left-hand side and we have a right-hand side. And the left-hand side has to be equal to the right-hand side. And what we've got is x add 2 is equal to 10. What number that if I add it to 2 is going to equal 10? Now, what we need to establish is what the principle of what we're trying to do when we're solving an equation. And that is to find the value that will make the left-hand side equal to the right-hand side. A way of doing that, and this is how I used to teach it. In the early days, I'd used to put a box around our unknown, which in this case is x. So a box add 2 is equal to 10. What needs to go in the box? Well, hopefully you'll be saying, well, the box must equal 8. And the reason why you say that is because 8 add 2 is equal to 10. Now, because the box, as we've shown here, is x must equal 8. So that's actually the solution to our equation of x add 2 is equal to 10. If we, for example, had, let's just scroll down. So if we had x add 6 is equal to 15, what number such that if we add 6 to it is going to equal 15? Again, so we put a box around our x, that's our unknown. What number must go in the box? And of course, hopefully you'll be saying, well, that must be 9, because 9 add 6 is equal to 15. And because we've replaced x with the box actually means x, so x is equal to 9. And there is our solution to the equation x add 6 is equal to 15. The next kind of equation is something that looks a little bit like this. You've got x subtract 5 is equal to 4. The principle is still the same. We put a box around our x. What number, such that if I subtract 5 from it, is going to equal 4? And of course, the answer to that should be 9. The answer to that is 9, because we know that 9 subtract 5 is equal to 4. We know that to be the answer. So x must equal 9. So that's the solution to our equation x subtract 5 is equal to 4. And if we wanted to do, say, x subtract 3 is equal to 7, you can always pause the video at any time and have a go at it yourself before I go through the solution. So do pause the video if you want to have a go at this on your own. But I'm just going to quickly go through this. So some number such that I subtract 3 from it is equal to 7. Well, that something must be 10, because 10 subtract 3 is equal to 7. So x is equal to 10. Our solution to x subtract 3 is equal to 7 is x is equal to 10. So the next kind of equation you might come across is something like this. 3x is equal to 18. Now, 3x is the same as 3 multiplied by x. So 3 lots of unknown is equal to 18. Well, what number such that if I multiply it by 3 is equal to 18? Well, of course, the answer to that is equal to 6, because 3 multiplied by 6 is equal to 18. So our solution to 3x is equal to 18, x is equal to 6. And let's just be a little bit different. Let's have 4y is equal to 20. You can have a go at this yourself, but what this is saying is 4 multiplied by some number is equal to 20. Well, what must I multiply 4 by in order to get 20? Well, that number is, of course, 5. 4 multiplied by 5 is equal to 20. So our solution is y is equal to 5. And then finally, x over 2 is equal to 7. X over 2 is the same as x divided by 2. I'll just quickly write that here. X over 2 is the same as x divided by 2. But it's just how we write it. Let's just bring that down here a minute so it's not going to get in the way. What number, such that if we divide it by 2, is equal to 7? Well, that number must equal 14, because 14 over 2 is equal to 7. We could also say 14 divided by 2 is equal to 7 as an alternative way of writing it, just so you're comfortable with this idea of having something over 2. So our solution to this equation is x is equal to 14. And just look at one more. Let's use the letter t. T over 6 is equal to 4. What number, such that if I divide it by 6, is going to give us the answer 4? Well, if you know your multiplication tables, you should know that that answer must be 24, because 24 over 6 is equal to 4. So our solution to t over 6, t is equal to 24. We can, of course, take this idea further. We might have equations looking like this, and these are referred to as two-stage or two-step equations. We have 2x add 9 is equal to 11. We can use what we've done before to deal with this equation. At the moment, we've got two lots of an unknown. Add 9 is equal to 11. Now, you can do this with trial and error, just plugging in values. But just look at what I'm going to do. I'm going to put a box around our two lots of unknown. So we now have something add 9 is equal to 11. We've just been solving equations that look like that. Something add 9 is equal to 11. Well, that something must equal 2, because 2 add 9 is equal to 11. But we put a box around 2x. We now have 2x is equal to 2. We've just been solving questions like this. Two lots of something is equal to 2. That something must equal 1, because 2 multiplied by 1 is equal to 2. So x must equal 1. And we can check this. So we've got 2x add 9. If we plug in our value for x, which is 1, we've got 2 multiplied by 1 add 9. That, of course, is equal to 2 add 9. Of course, that is equal to 11. So we know that this answer is correct. And let's scroll down. Let's do another one. 3x subtract 4 is equal to 20. Again, let's put a box around our unknown. We've got 3 lots of our unknown. Subtract 4 is equal to 20. Now, by putting a box around our unknown, we've got something subtract 4 is equal to 20. That something must be 24, because 24 subtract 4 is equal to 20. But that something we know is 3x. 3x is equal to 24. Now, we've just been solving questions looking like this as well. So 3 multiplied by something is 24. That something must equal 8. So x must be our solution to this equation. And we can check this. We've got 3x subtract 4 is equal to 3 multiplied by, let's substitute in our value of x, which is 8. 3 multiplied by 8 subtract 4 is equal to 24. Subtract 4, sorry, let's scroll down here, is equal to 20. And just doing one more, t over 2 add 7 is equal to 10. We put a box around our unknown. So we have something add 7 is equal to 10. That something must equal 3. But remember that something is t over 2. So t over 2 is equal to 3. So we have a number divided by 2 is equal to 3. That something must equal 6, because 6 divided by 2 is equal to 3. So our solution is t is equal to 6. Now let's go back over these questions, and let's now have a look at what we mean by transposing. So this was the first equation that we looked at. X add 2 is equal to 10. So let's write that down over here. X add 2 is equal to 10. We ended up x is equal to 8. So we've gone on a kind of journey where we started off with x add 2 on one side and 10 on the other. So here's our left-hand side, and I will refer to the left-hand side and the right-hand side. But we started off with x add 2 on the left-hand side and 10 on the right-hand side, and we finished with x on the left-hand side and 8 on the right-hand side. So in this particular kind of equation, what we're trying to do is we want to get our unknown on its own, on one side of the equation, and our numbers on the other. We have x add 2 is equal to 10. I need to get rid of this 2. The opposite of addition is subtraction. So if I, and this is how we do it, if I subtract 2 from both sides, I'm going to put all the lines in just so you can see what's happening. X add 2 subtract 2 is equal to 10 subtract 2. X add 2 subtract 2 is x. Yes, because you're starting with something, you add 2 to it, and then you subtract 2 from it, you're going to end up with that something. And remember, the whole idea was to get rid of the 2. X is equal to 10 subtract 2. Have a quick look here. We've got, I'm just going to highlight it, we have got subtract 2 here. And here's our add 2. The 2 that we started with on the left-hand side of the equation has now gone over to the right-hand side of the equation. It's gone from +2 to -2. And that is what we're referring to as transposing, the moving of one term in an equation from one side of the equation to the other side. So the 2 has gone from +2 to -2. And of course, 10 subtract 2 is equal to 8. And there's our answer. Let's look at the next one. So here's our left-hand side. So we have x add 6 is equal to 15. Here's our left-hand side, and here's our right-hand side. We're going to end up with x is equal to 9. The first thing we need to do, let's look at the left-hand side. Our x is on the left-hand side. We want to get x on its own. We have add 6. So we need to subtract 6. So we end up with x add 6, subtract 6, so it's not very clear there, is equal to 15 subtract 6. So something, looking at the left-hand side now, x add 6, subtract 6. Something add 6, subtract 6 is just that something. X is equal to 15 subtract 6. And again, look what's happened. Our +6 on the left-hand side of the equation. We have now moved it over to the right-hand side of the equation. And it's gone from +6 to -6. That's what we mean when we're talking about transposing. And of course, 15 subtract 6 is equal to 9. Let's look at this equation. X subtract 5 is equal to 4. Here's our left-hand side, and here's our right-hand side. X subtract 5 is equal to 4. We want to get the 5 over to the other side of the equation. We're going to write down what we're going to do. The opposite of subtracting 5 is adding 5. So we're going to add 5 to both sides of the equation. X subtract 5 add 5 is equal to x. Remember, the whole point was to get x on its own. Is equal to 4 add 5. Again, let's look at what's happened. We started with -5 on the left-hand side of the equation. To get the 5 from the left-hand side over to the right-hand side, we're going from -5 to +5. And of course, the answer to that is x is equal to 9. The reason why I've put this stage in here is because I want you to see what's going on. But when we're transposing, and when you become more comfortable with transposing, you don't necessarily have to put in every line. But as you're trying to understand what's going on, it's quite useful to put every line in. Let me show you how you can just cut down on the amount of work that you're doing. We have x subtract 3 is equal to 7. So we have x subtract 3 is equal to 7. I want to get my x on its own. We have -3 here, so I'm going to add 3 to both sides. Now I know that x subtract 3 add 3 is going to give me x, because that's the whole idea. I want to get x on its own. So I end up with x is equal to 7 add 3. So what I've done is I've missed out this line up here. I'm just shading in. I've not bothered doing that line there. All I've done is I've jumped straight to x is equal to, because that was the purpose of adding the 3 here. Now, of course, x is equal to 10, and there's our answer. Now we have 3x is equal to 18. 3x is equal to 18. 3x means 3 multiplied by x. The opposite of multiplying is dividing. So what I'm going to do, because I want to get x on its own. Remember, we're going to end up with x is equal to 6. So to get the x on its own, I'm going to get rid of this 3. I need to get rid of this 3 here. So what I'm going to do is I'm going to divide both sides by 3. Notice how I write it down when we're dealing with algebra. 3x over 3 is equal to 18 over 3. We then end up with x is equal to 18 over 3, or 18 divided by 3. And of course, 18 divided by 3 is equal to 6. And if we look at this question here, we've got 4y is equal to 20. So 4 multiplied by y is equal to 20. I want y on its own. So to get y on its own, the opposite of multiplying by 4 is divide by 4. 4y over 4 is equal to 20 over 4. A number multiplied by 4 and then divided by 4 is the number that you started with, is 20 divided by 4. So y is equal to 5. Now, let's just pause that. Of course, I should have been the whole idea about transposing, and I didn't actually talk about this. Let's just quickly go back up to this first question where we talk about 3x with 3x is equal to 18. Let's just quickly look at what's gone on. Left-hand side and right-hand side. Let's just quickly look. The 3 started on the left-hand side as a multiplication. It ended up on the right-hand side as a division. Similarly, we had 4y is equal to 20. So the 4 went from being a multiplication on the left-hand side to being a division on the right-hand side. And finally, x divided by 2 is equal to 7. We need to get the 2, which is a division, over to the other side. You might already know where I'm going to go with this. If I've got a number and I'm dividing it by 2, the opposite of dividing by 2 is multiplying by 2. So I'm going to end up with x over 2 multiplied by 2 is equal to 7 multiplied by 2. I'll write it out like this. There's a neater way in which to do this, but let's just write it like that so you can see what's going on. We end up with x on its own, and we end up with 7 multiplied by 2. Let's just pause it there. We have seen now that this 2, which is on the left-hand side of the equation, let's just write that in, left-hand side and the right-hand side. The 2 has gone from a division on the left-hand side to a multiplication on the right-hand side. And of course, x is equal to 14. I'm going to be a little bit more mathematically sophisticated, if that's at all possible, with the last question. T over 6 is equal to 4. Here's our left-hand side and here's our right-hand side. I'm dividing by 6, t divided by 6. To get rid of that 6 over to the right-hand side, I'm going to multiply by 6. So t is equal to 4 multiplied by 6. t is equal to 24. Again, notice the 6 has gone from a division on the left-hand side to a multiplication on the right-hand side. Let's look at two-stage equations using transposing. So when we're looking at two-stage or two-step equations, the process is still the same. Let's have a look at this question here. We have 2x add 9 is equal to 11. Let's quickly write this down again. 2x add 9 is equal to 11. We're going to end up with x on its own down here. And we know that the answer is going to be 1. I'm actually conscious. Let's just quickly move that over there a minute. Just give us a bit more space. We've got 2x add 9. The first thing we need to deal with, we want to get our x's on their own. So we want to get x here on its own. So we need to get rid of the 9. And we want to get it over to this side of the equation. We know that in order to get rid of a plus 9, we need to subtract 9 from both sides. So we're going to do a subtraction. So I'm just going to make a little note in brackets. We're going to subtract 9 from both sides. 2x, add 9. I'm going to put this line in just to be sure you know what's going on. So I've subtracted 9 from the left-hand side and the right-hand side of the equation. It's always about this balance. The left-hand side must always equal the right-hand side. We end up with 2x is equal to 11 subtract 9. 2x is equal to 2. Look at what's happened. We've ended up with 2x is equal to 2. That's exactly what we got over here when we were doing it without transposition. We were trying to get the 9 over to the other side. We wanted to find out what 2x was equal to. We now know that 2x is equal to 2. The next stage is we now need to find what 1x is equal to. We've got 2 lots of x. 2 multiplied by x. The opposite of multiplying is dividing. So we therefore need to divide both sides by 2. So 2x divided by 2 is equal to 2 divided by 2. So x is equal to 2 divided by 2. X must equal 1. And of course, that's what we end up with as our answer. Let's look at this question. I'll rewrite it. We have 3x subtract 4 is equal to 20. Here's our left-hand side and here's our right-hand side. The first thing I want to do is we've got 3x subtract 4. We would like to get our 3x, we want to get this on its own. So we need to get rid of the minus 4x. We want to get that over to the other side. To get our 4 over to the other side, we need to add 4. 3x subtract 4, add 4 is equal to 20, add 4. The left-hand side must equal the right-hand side. What you do to the left-hand side, you must do to the right-hand side to maintain the balance. 3x is equal to 20, add 4. 3x is equal to 24. And of course, that is what we have over here at this time. So this first stage when we were solving the equation here was to get the 3x on its own. The next stage now is to get x on its own. So we have 3 lots of x. I want to get this 3 over here. It's multiplied by 3. So therefore, we have to divide by 3. 3x divided by 3 is equal to 24 divided by 3. So that means that x must equal 24 divided by 3. X must equal 8. And that, of course, is what we have over here. And finally, we have t over 2 add 7 is equal to 10. Here's our left-hand side, and there's our right-hand side of the equation. The first thing we want to deal with is this 7. We want to get that 7 from the left-hand side over to the right-hand side of the equation. It's plus 7. The opposite of plus 7 is subtract 7. So if we subtract 7 from both sides, we have t over 2 add 7 subtract 7 is equal to 10 subtract 7. So we end up with t over 2 is equal to 10 subtract 7. T over 2 is equal to 3. And of course, that's what we've got over here at the moment. So we now found out what t over 2 is equal to. We now need to find out what t is equal to. So we have t divided by 2. We need to get that 2 from the left-hand side over to the right-hand side. The opposite of dividing by 2 is multiplying by 2. I'm going to write it like this. You can write it like this. 2t over 2. It's the same thing. So I'm just writing it differently. Is equal to 3 multiplied by 2. So t is equal to 3 multiplied by 2. T is equal to 6. And of course, that's the answer that we have over here. I'm putting in more steps than you need to. The reason why I'm doing that is I just want to make sure that you can see what's going on. But as you practice these kinds of questions, you'll be able to cut down and reduce the amount of work that you need to show. For example, let's just have a look. If I did x add 8 is equal to 12. So the process that I'm thinking of is I know I need to get that 8 over to the other side. That's what I'm thinking. So if I'm adding 8, I'm going to subtract 8 from both sides. X is equal to 12 subtract 8. X must equal 4. And I know this is true because if I check it, 4 add 8 is equal to 12. That is correct. If I was, for example, if I did, and this is a two-step equation, if I did 4x add 6 is equal to 22. The first thing I'm looking at is I want to get my x on its own. So I need to get rid of this 6 over from the left-hand side over to the right-hand side. The opposite of adding 6 is subtracting 6. So I need to subtract 6 from both sides. So I end up with 4x. Remember, the whole idea is we want to get the x's on their own. So we've got 4x on its own, and we've got 22 subtract 6. 4x must equal 16. Now I want to get this 4 over from the left-hand side to the right-hand side. The opposite of multiplying by 4, because it's 4 lots of x, is dividing by 4. So I'm going to divide by 4. I get x on its own. I've got 16 divided by 4. X must equal 4, and there's the solution. So that's how you can solve one-stage and two-stage equations. Here are 4 questions for you to have a go at. Pause the video, answer the questions, and I'm going to go through the answers. I'm assuming now that you've had a go at these questions. Question 1 and question 2 are just one-stage equations, and question 3 and question 4 are two-stage equations or two-step equations. Let's quickly look at question number 1. X subtract 7 is equal to 3. I need to get, well, basically what I want to do is I want to get the 7 from the left-hand side over to the right-hand side. That's what I'm thinking. We've got subtract 7, so the opposite of subtract 7 is I'm going to add 7. I end up with X is equal to 3, add 7, X is equal to 10. Question number 2, I've got X divided by 7 is equal to 9. I need to get the 7 from the left-hand side of the equation over to the right-hand side. We're dividing by 7, so to get it over to the right-hand side, we need to multiply by 7. X is equal to 9 multiplied by 7. X is equal to 63. Question number 3. We've got 4x subtract 3 is equal to 9. So the first thing I want to do is I want to get my 4x on its own. So the 3 needs to go from the left-hand side over to the right-hand side of the equation. Because it's minus 3, I have to add 3. So if I add 3 to both sides, I end up with 4x is equal to 9, add 3. So 4x is equal to 12. I now need to get the 4 from the left-hand side over to the right-hand side of the equation. I'm multiplying by 4. So in order to move the 4 from the left-hand side over to the right-hand side, I have to divide by 4. So x is equal to 12 over 4. 12 divided by 4, x is equal to 3. And with the last question, we've got x divided by 5, or x over 5, plus 8 is equal to 12. So the first thing I need to deal with is this 8. I need to get it from the left-hand side over to the right-hand side. It's plus 8, so I need to subtract 8. So I end up with x divided by 5 is equal to 8 add 12. So x over 5 must equal 20. I now need to deal with this 5, get that over to the from the left-hand side over to the right-hand side because I want to get x on its own. I'm dividing by 5 on the left-hand side, so that means I must multiply by 5. So I end up with x is equal to 20 multiplied by 5. X is equal to 100. That's a brief overview of solving equations. I hope it's made some sense to some of you out there. But thank you for watching, and keep an eye out for my next video. I'll try and get some more videos up of different things just to help you out while you're at home. Thank you for watching.